Okay, question number 6. An artificial satellite orbits the Earth at a height of 400 km above its surface. Now, take it carefully so you can see the bulb here. Okay, it says above its surface. Now, the satellite has a mass of 5,000 kg. The radius of the Earth is 6,400 km, and the mass of the Earth is 6.0 times 10 about 24 kg. So for this satellite, calculate A, the gravitational force experienced, B, its centripetal accelerations, and C, its orbital speed. Okay, so let's start to do the calculation. Oops, sorry, I have to call up my pen first. Okay, so 6A. Okay, so 6A required to find the gravitational force experience. Okay, so F equal to G m1 m2. So I can call up the Newton gravitational law. Okay, to find the force. So again, this is very typical. This is a gravitational constant. Now, what is the mass of the Earth? Is 6.0 times 10 power 24 kilogram. Okay. Now, what is the mass of the satellite? It's about 5,000 kilogram. Okay. Divided by, now, just now I mentioned, be careful on the questions where it says above its surface. Okay. So remember that. Now, what is the distance? Now, what is the distance? So the distance is not 6,400 kilometer. It's not also 400 kilometer. It should be 6,400 kilometer plus another 400 kilometer. Okay. Now, and then times kilometer and square it up. Okay. Most of the students will very careless. They make mistakes at okay. I will call up change the color. Change the color first. Most of the students will make a mistake when they at this part and also at this part. Okay, some will just square it up straight away, square it up, and forget about the kilometer. And you have to understand that you have to convert it back everything to the SI unit. Okay, so equal to, okay, you go through everything, you will finally reach the answer. You put in everything in the calculator. Okay, so you got the answer as this. Okay, now part B. So part B want you to find what is the accelerations. Okay, what the acceleration of the satellite. Okay, so you know the force already. Where is which is this. Now I want to know the accelerations. Very simple. Equal to ma. Okay, so ma equal to 4.3 times 10 power 4. So my A will be equal to 4.3 times 10 power 4. Sorry, this is Newton. This is Newton divided by 5,000 kilogram. So I will get my answer as 8.6 meter over second square. Okay. So part C. Alright, part C. Part C want you to find the speed. Okay, want you to find the speed. It's also very simple. Okay, so speed, how speed related to the calculation that we are make now so far. Okay, so don't forget that we know that A will be equal to acceleration. Centripetal acceleration will be equal to A equal to V squared over R. Now you can see the relation of the speed and acceleration is coming up. Okay, so if I want to find the V, I must be square root of AR. Okay, so equal to square root of, now I have my A is 8.6. Now what is my R? Okay, now my R still the same. Don't forget about that. It's supposed to be 6,800 kilometer. Okay, same like A. Okay, sorry, same like part A. Okay, it's 6,800. It's not 6,400. It's not 400. It must be 6,000. So the radius of the use in this equation, and also the gravitational law, it must be from the center of the system. Okay, from the center of the system. Okay, now then you will get your answer as 7.6 kilometer second over second.